In this video, we're going to have a couple more examples with implicit differentiation. Okay, so for this problem, we have an equation, x natural log of y plus 5y equals 3x cubed. We want to find y prime, and then once we find that, we want to find y prime at the point, negative 1, 1. Okay, so we're going to start by taking the derivative of each term. So we're going to take the derivative with respect to x of x natural log of y, and we're going to take the derivative with respect to x of 5y, and the derivative with respect to x of 3x cubed. Now, most of these are not too bad, but this is a function times a function, which will be product rule. Okay, so when you do product rule, you have the first times the derivative of the second, which would be x times, this will be, since this is not just a y, it's a function of x, we will have chain rule. So the outside function is natural log. The derivative of that is 1 over it. And then you also have, it'll be y prime, plus the second function times the derivative of the first, and the derivative of x is just 1. Okay? So that's just this first term right here. That's its derivative. Product rule. Within that product rule, we have a chain rule right here, because you have the outside function, there's natural log. This is not just a y, it's not just a variable, it is a function y in terms of x. So the derivative of the inside is y prime. And then you have log of y times the derivative of x, which is 1. Okay? This one is a chain rule. The derivative of 5 times the function y, it's just 5. And then the derivative of that function y is y prime, that inside function y. Okay, and then on this side, it'll be 3 times 3 x squared, so it'll be 9x squared. Okay, what we need to do next is solve for y prime. Okay, we have let's maybe make it look a little nicer first, so we don't get anybody lost. Okay, so I'm going to move this over to the other side. And then I have two terms that have a y prime in it, so I moved that over. I have an x over y prime and a 5y prime. Well, just like if I had ax plus bx, that coefficient, when I add them together, would be a plus b. Same thing here. I will have x over y plus 5 y prime. Okay, I am running out of room here, so I'm going to add some more lines here. Have it looking too messy there. Okay, and then, sorry, it's equals here. Remember that if you have something bothering y by multiplication, you divide it on both sides. So this will end up being y prime equals 9x squared minus natural log of y over x over y plus 5. Okay. There are ways to make that look a little nicer. You can combine the bottom as a common denominator, which would give me 9x squared minus natural log of y over x plus 5y over y. I just changed 5 into 5y over y and then combined. And then remember that when you are dividing fractions, same change flip. So really probably would be nicer to write it as that y prime equals y times 9x squared. You can't see it, I'm sorry. That way you can read it better. Y prime equals y times 9x squared minus natural log of y divided by x plus 5y. Okay. The next part of this problem said we wanted to find y prime at negative 1, 1. Okay, so what this gives us is an x value and a y value. And I'm going to take those and plug them in. So I'm just going to say y prime equals 1 times 9 times negative 1 squared minus natural log of y, which is 1, divided by negative 1 plus 5 times 1. Okay, and that should be on the top. You have 9 because this is 0. Natural log of 1 is 0. So you have 9 times 1, which is 9. So you have 9 on the top. And then negative 1 plus 5 is 4. So this gives you 9/4. Right? Probably nicer looking than you thought. You see all that mess, you think it's going to be some kind of horrific mess, but when you get to the final answer, it's just 9/4. You have a second example. Which is for y squared minus xy minus 12 equals 0, find the tangent line at x equals 4. Okay. For a tangent line at a certain spot, remember that we have several steps. The slope of the tangent line, though, is the derivative. All right, so first thing we need to do is find the derivative. So I'm going to take the derivative of the first term minus the derivative of the second term and minus the derivative of the third term equals the derivative of the term on the other side. Okay, so I have the derivative of y squared, the derivative with respect to x of y squared. We'll use a chain rule here. So we have 2y times y prime. Right here we have x times y. This is product rule, okay, because this is x times y as a function of x. Okay, so we'll have minus, I'm just going to put in parentheses for right now, have the first function times the derivative of the second, which is y prime, plus the second, which is y, times the derivative of the first, which is just 1. Okay, and then the derivative of 12 is 0. And the derivative of 0 is 0. Okay, so just simplifying, we have 2y times y prime minus x times y prime minus y equals 0. So again, solve for y prime. So I'm going to move the y over to the other side. I'm going to group my like terms. So the coefficient on y prime will be 2y minus x. So I divide both sides by 2y minus x. Okay, so that's y prime. I then, in order to find the slope, so this is y prime. Y prime equals y over 2y minus x. Okay, the slope of the tangent line is the derivative y prime at x equals 4. Okay. And then y value of, well, we don't know. We need to go back to the original function to find the y value of this point. Okay, so what we do is we take y squared minus xy minus 12 equals 0, plug in 4, and that'll give me the y value. Plug in 4 in place of x. So that gives me y squared minus 4y oh, I should have plugged that in to start with. Let's see. Hang on. I messed something up somewhere. No, that's right. I'm going to solve here. I got a quadratic. Okay. Thought I had messed something up here for a minute. So we need to solve this equation. This factors as negative 6 positive 2. So you get y equals 6 or y equals 0. Okay, so we actually have two different points, or two different points we're going to use here. So we're going to have two different tangent lines. Okay, you notice in the directions it did have this little possible S here. So we're going to have two, I'd forgotten that. That's why I thought I did something wrong for a second, but I did not. I just forgot that part of it, that it had a little S here. So let's start by finding the tangent line at 4, 6. Okay. So we need to find the slope. So the slope here is the y prime. So we have y is 6 over 2 times 6 minus 4. Okay, which is 6 over 8, which is 3/4. Okay, and then you can use point slope form. Y minus 6 is 3/4 of x minus 4. And then just distribute 3/4 times 4 is 3, then add 6. So y equals 3/4 of x plus 3. That's my first tangent line. My second tangent line is running out of colors. Oh, we'll use purple. Okay, so let's next find the tangent line at 4, 0, because my other y value was 0 when I solved this quadratic. So I found this quadratic by plugging in 4 into the original function, which was y squared minus xy minus 12. I solved that quadratic and got the two places for x equals 4, so there will be two different tangent lines. So again, I use that y prime first to find the slope. So here was the slope this time. Here will be the slope this time. So I take 0 over 2 times 0 minus 4. So that is, no, wait. 0. Should be -2 here. I was like, wait a minute. -2. I think when I thought I had messed it up, I just miswrote that. You ever have that cascade effect where you think you messed something up and then it makes you mess something else up? Well, there it was. It's probably talking and thinking at the same time and messed up. So, there you go, -2. So when you do this, I was looking at that, I'm like, that should not be 0 for that slope. -2 over -8, which is 1/4. So again, plugging into point slope form, you have y minus -2 equals 1/4 times x minus 4. So y plus 2 is 1/4 of x minus 1. So y will equal 1/4 x minus 3. Okay, so these are my 2 tangent lines. And that's it. That should be about the hardest thing you have in this section is the tangent line problems, because there's just so many multiple steps.